Hey math fans, we're on section 2.6.2. Let's get started. Today we're going to be comparing two exponential functions. So it's going to be important when we start discussing the rate of change that we specify what the interval is going to be. But we're also going to compare the y-intercepts as well. Compare the properties of each of the following two functions over the interval 0 less than or equal to x less than or equal to 16. Now, first things first, we could take a look at the y-intercept for a function a, which they'll also be referring to as f of x, is going to be around 850. Now, for the second function, the y-intercept when x is equal to 0 is also going to be 850. So for the y-intercepts, we don't necessarily need the interval, but when we get to the rate of change, we need that interval. So let's take a look at the solution for this. And like I said, both of the y-intercepts for each of these functions, f of x and g of x, both have a y-intercept of 850. In other words, they are equal. When analyzing the rate of change, though, we have to specifically look at the interval 0 less than or equal to x less than or equal to 16. So first things first, what is the y value when that x is going to be equal to 16? Well, it's basically, what's the y value here for the graph or function a? It's going to be 1600. So we're going to be using 16 comma 1600, and we're also going to be using 0, 850, because the other end of the interval is at 0. And we get 46.875. Now for function b, which is in the form of a table, we're going to only be using when x is equal to 16 and when x is equal to 0 as specified by the interval. We're only going to be using these two coordinate points. And as you can see, it gets plugged into the rate of change formula right here, and you get 39.43 after you're finished with all the calculations. Finally, summarize your findings. The y-intercepts for both functions are the same. However, the graphed function f of x has a greater rate of change over the interval 0 less than or equal to x less than or equal to 16. Example 3, a pendulum swings to 90% of its previous height. Pendulum A starts at a height of 50 centimeters. It can be mapped by the function f of x is equal to 50 times 0.9 raised to the x power. So there's your first function, function f of x. Now, g of x is represented by the table down here. And notice they have to give us an interval because both of these are exponential functions. First, let's analyze what are the y-intercepts for each of these functions. And again, the y-intercept is always found when we substitute in 0 for x. And when we substitute in 0 into f of x, you're going to get 50. Now for the other one, for g of x, we're going to be using the table here. And we just look and see, well, wait, where is x equal to 0? When x is equal to 0, the g of x is equal to 100. So the y-intercept is 100 for the second equation, the second function. To determine rate of change, we need the interval to be specified. So in other words, when x is equal to 5 and when x is equal to 15, we're going to be using those coordinate points. So you need to get a y value using this f of x function. I need to substitute in 5, and then I need to substitute in 15. And you get these values right here, and they go into your rate of change formula, and you get negative 1.923 centimeters per swing is the rate of change for f of x. For g of x, we're going to use the same interval, 5 less than or equal to x less than or equal to 15. So we're only using when x is equal to 5 and when x is equal to 15. And we need their corresponding y values, or what are the values of g of x at both of those points. So now these numbers will go into the rate of change formula, as you can see right here. And those simplify to a value of negative 3.846 centimeters per swing for pendulum B, or in other words, g of x, that rate of change. Finally, summarize your findings. The y-intercept for pendulum A is less than the y-intercept of pendulum B. That means that pendulum B begins higher than pendulum A, and the rate of change for pendulum A is less than the rate of change for pendulum B. That means pendulum B is losing height faster than pendulum A. Remember, we're going to be looking at the average rate of change. We're going to be looking at that absolute value. The higher absolute value will be the higher rate of change. And that's going to do it for this section. We'll see you in class.